All right, welcome to the Explainer. Today, we are cracking the code on the invisible engines that literally run our entire digital world. We're talking about databases. Whether you're building an app, managing an inventory, or gearing up to absolutely crush a Cambridge Computer Science exam, nailing the fundamentals of data organization is just non-negotiable. So let's jump right in and demystify single-table databases and SQL. Oh, and before we get too deep, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations.
Here's our roadmap for today. We're hitting 1. Anatomy of a database. 2. Essential data types. 3. Unlocking primary keys. 4. Speaking SQL. And finally, 5. Exam success strategies.
Section 1. Anatomy of a database.
So let's start with the physical structure. At its core, a database is simply a structured collection of data. It's built specifically so we can pull out exact information whenever we need it. Think about a simple store inventory. You've got descriptions of items, their prices, maybe some pictures. If you just threw all that into a messy text document, it'd be a nightmare to manage, right? But by structuring it, you can actually search, filter, and make sense of the whole shebang.
Now, what's really interesting is how this looks visually. When we talk about a single table database, it literally means just that. The database contains only one table, kind of like a basic spreadsheet. But the terminology we use for the parts of this grid is incredibly specific.
Here's your golden rule, so lock this in. Each record is a row in the table, and each field is a column. You've got to memorize that. A record holds all the data about one specific item or person. A field is the category of that data. The crucial takeaway here, you can always add or delete rows as new stuff comes in, so the number of records varies. But the columns, the fields, those are fixed. Every record has to have the exact same number of fields.
Section 2. Essential data types.
All right, once your fields are set, you have to decide exactly what kind of information is allowed to live inside them. A data type classifies how data is stored, how it's displayed, and what operations you can perform on it. When you create a field, you must select a type for it. As you can see mapped out here, we've got standard ones like integer for whole numbers, real for decimals, date and time, but there are a few that constantly trip people up.
Like this comparison right here. It is so easy to mix these two up. Text, which is also called alphanumeric, allows for a string of multiple characters, like a full name or a street address. But character, that is strictly for one single isolated character. Think of a multiple choice answer where the field can literally only hold an A, B, C, or D. Picking the wrong one here is a classic exam mistake, so keep them straight.
Another incredibly powerful data type is the Boolean. A Boolean field can only ever hold one of two values. It represents a strict binary choice, true or false, 1 or 0, yes or no. It's perfectly designed for things like, is this item in stock, or has this student paid their fees?
Section 3. Unlocking primary keys.
Okay, so we've got our grid, our data types are locked, but now we hit a major organizational roadblock. If each record contains data about a single person or item, how do we single out just one record without any mix-ups? What if two people have the exact same name, or two products cost the exact same amount? How does the database actually know which one we mean?
Well, the answer is the primary key. This is a specific field whose entire job is to uniquely identify a record. Its absolute superpower? The values in this column are never repeated. Every single entry has to be 100% unique. It's the absolute anchor of your entire database.
Section 4. Speaking SQL. So, our table is perfectly structured, our types are locked, and our primary key is set. Now, how do we actually ask the database for things? We do it by speaking SQL, Structured Query Language. This is the standard language used to write scripts or lists of commands that extract exactly what you need. It's your direct line of communication with the data. SQL is built on a few really logical core commands. Every query starts with select, which grabs the specific fields you want to look at. Next is from, which tells the database which table to check. Where is your filter? It only pulls records that match a condition you set. Then you have order by to sort your results. We've also got math commands like sum to add values up and count to tally the number of rows matching your condition.
Here's a great look at these commands in action. Look at this first script. Select, item description, price, from items for sale, where price is greater than 10.00, order by price. In plain English, we're just telling the database, hey, show me the descriptions and prices of items over $10 and sort them by price.
It's incredibly logical once you break down the building blocks. Real quick, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations.
Section 5. Exam Success Strategies.
All right, we've nailed the theory. Now let's apply it to a real-world exam scenario. Take a look at this student room database challenge. It tracks student accommodation with 3 fields: name, block, and room number. A classic examiner move here is asking you to explain why none of these current fields can be a primary key.
Let's analyze the data. Remember our rule for primary keys? Absolute uniqueness. Name fails because, look, we have 2 different students named David Smith. Block fails because multiple students live in Block A. And room number fails because they share rooms. David Chow and David Smith are both in room 129. Since there are duplicates in every single column, a primary key just isn't possible here.
So when the exam asks you to suggest a field to add as a primary key, look at the difference in these answers. The low-level answer just says, use the name, no need for an extra field. That completely ignores the duplicate David Smiths. But the high-level, top-tier answer? It suggests inventing a brand new field, like Student ID, and gives a specific example like ST12345, that guarantees uniqueness and perfectly solves the database's structural flaw.
Looking at the actual examiner's comments gives us a huge tip. When a question asks you to explain something, like why a field isn't a suitable primary key, you must give a reason in the context of the question. You can't just state a fact. You actually have to explain why the duplicate data breaks the primary key rule.
And finally, if you're asked to write out the output of an SQL command, format is everything. The high-level answer draws a clean table, uses only the correct fields, and sorts the rows perfectly based on the script. The low-level answer? It throws in commas and random punctuation that nobody asked for, drops a field completely, and sorts the data wrong. When you're acting as the database output, be precise, be structured.
We've covered a massive amount of ground today, from the basic grid of rows and columns, all the way to querying data with SQL and absolutely crushing those examiner expectations. I want to leave you with this final thought. If you were designing a single table database of your own life, interacting with thousands of other people, what single field would you use as your ultimate, unrepeatable primary key? Let us know in the comments. And one last reminder, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Thanks for joining me on The Explainer, and keep questioning the data around you.